All right, we're going to look at chemical equations today. And so the first thing we want to do is we want to take this and we want to break this down into a few components here. So there are a couple of things that you need to know about chemical equations. The first thing is when I look at these things right here, see how they're divided up by the pluses and the arrow, right? These are all the chemicals that are actually in the equation. And rather than calling them chemicals or something like that, we call these species. If you want to draw an analogy to algebra, right? Your algebra teacher might call, if you're looking at an equation in algebra, they might call them terms, and it kind of means the same thing in chemistry here, right? Instead of calling them terms, we call them species. And the reason we call them species is because they can be sort of three different things. This first one is an element all by itself. That's literally an atom. The second one is two atoms bound together into a molecule. Or you could have them, for example, this is two ions stuck together, really three ions, but more of that in just a second. But you got sodium ions and oxygen ions stuck together, and you know that's an ionic compound. So we can have a species that could be multiple things, right? It could be an atom, could be a molecule, could be a compound, and so we just call them species. The next most important thing, and some of you may remember this from a previous science class, is this arrow right here in the middle. This arrow right here is very special. We don't call that arrow. We don't call that, you hear people come up with all sorts of weird names for it. That is the yields arrow. All right, so whenever you're reading this, you might read it Na plus O2 yields Na2O. Right, that's just how we call it. That arrow is very special because it divides things in half. It divides this in half. It divides it perfectly in half, right? No, sort of, kind of, not really. The yields arrow divides it in two different pieces. The piece on the left are what we call the reactants. So all these species on the left-hand side are reactants of this chemical equation. So we have sodium reacting with oxygen to generate sodium oxide. The stuff on the right are what we call products. So the reactants react to produce the products. And it's sort of like what's happening in time. I take these two things, I put them together, they're going to react and yield this thing over here on the right. Ideally, we'll start off with this on the left, we'll wind up with this thing on the right. And so that is the basic breakdown of a chemical equation. There's something wrong with this, right? If we look, everything on the left should equal everything on the right. And if you look on the left over here, we have one sodium. On the right, we have two sodiums, though. On the left, we have two oxygens. On the right, we only have one oxygen. So where'd the extra sodium come from? Where'd the extra oxygen go to? Right? We can't convert one chemical or one element into another element. Not yet. We'll get to that at the end of the semester. But what's going on here, right, is this reaction is, to use a very special word here, it is unbalanced. And I like that word because I've been called unbalanced a little bit in my life too, right? But unbalanced, right, is what this equation is. And so what we need to be able to do is take an equation like this and be able to balance it. So to do that, you've got a balancing chemical equations notes here. If you need to go ahead and find that, pause here. All right? And it's in CAMI. I'm going to just show you how to balance a chemical equation right here in CAMI. I'm going to do this for one of these in this video. And then I'm going to post a couple of other videos later on that show you how to do more of it. All right. So the first thing that you need to do, I don't want to add a signature. Sorry, Cami. First thing that you need to do is we're going to draw two lines on this thing. Okay, two types of lines, I should say. This one's only going to get two, but sometimes you'll draw more than two. Right. So first things first is find that yields arrow, and we're going to draw a big thick line through that. Right. Remember, that's going to divide our equation in half. On the left, we've got our reactants. On the right, we've got our products. And it's kind of nice that my camera here is backwards, right? This is left and this is right. This is great. So reactants and products. I could even put myself underneath it. Look, reactants and products. Oh, digital. The wonders of digitalness. All right. Enough of that. All right. Now we're going to draw, I told you we're going to draw two lines. So one line is a thick line that divides reactants and products. Another line, we need to know where these plus symbols are. So I like to draw a dashed line for the plus symbols, all right? And then we're going to come back in here. We're going to make a chart out of this. On the left-hand side, I'm going to list all of the elements that we find in this thing. And this one only has 2 elements. Check. All right? And then I'm going to draw a nice horizontal line to divide those guys up. What we've done here is we've gridded off this problem. So what we're going to do is to figure out what we're going to write in this box right here, we need to see how many sodiums there are in this species right here. Right? So it's that simple. So just wherever you are, you put your finger there. If I can put my finger on the screen, but that doesn't help you guys out too much. But we're going to look right here in this square. How many sodiums are in this thing? Well, remember, there is no subscript on that sodium. So what does that mean? How many sodiums are there? That's right. There is 1 sodium there. How many chlorines are there? Well, there ain't any. So I'm going to draw a flat line there. You could put a 0 here, a flat line. You can put an X through it, whatever. Just know that means there's no chlorines there. Same thing here. How many sodiums are in this species? Well, there aren't any. I'll draw a flat line there, just so I don't confuse myself by looking at it later. How many chlorines are there? Well, notice this one's got a subscript of 2, so there are 2 chlorines in this thing. Over here on the right-hand side, how many sodiums are in here? There's 1. And how many chlorines are in here? There's also 1. So now what we're going to do is I'm going to switch ink colors, because I can. The magic of digitalness, right? If you're doing this at home, you've got a different pen that you want to try, you can do that one. What I'm going to do is I'm going to look at these, and I'm going to write the equation. I'm not going to write the equation every time, but in my brain, I need to be able to see it this way. So here, on the left-hand side, we've got a 1, and that dashed line means plus, right? Up here, there was a plus here. That's just exactly what that means right there. 1 plus 0, because there's nothing there, equals, the solid line here means equals 1. Is that true? Does 1 plus 0 equal 1? Does 1 plus 0 equal 1? Well, let me pull out my calculator. Really working at that calculator right there. Yeah, hopefully, yeah, this is the humor, folks. This is all I got. All right, 1 plus 0 definitely equals 1. So check. So that part is balanced. Awesome. This is easy. Let's go to the next one. All right, next one we have 0. And the dash line means plus 2 equals 1. Okay. 0 plus 2 definitely does not equal 1. So this part is unbalanced. That part is unbalanced. So we need to fix that. And the only way to fix that is we are going to add coefficients in the reaction up here. Okay? We need to add coefficients to these. And just like in algebra, when you add a coefficient, right, if I have x and I put a 2 in front of it, that means 2 times x. We're going to do the same thing here. If I put a 2 in front of this chlorine, we're going to multiply all those chlorines by 2. That's going to give me 4 chlorines. I feel like that's heading in the wrong direction, though, don't you, right? Probably don't want to do that. Let's think about putting a 2 here. What happens if I put a 2 right here? If I put a 2 there, here's the thing. It's going to change everything underneath it. So whenever you do this, remember, I'm multiplying everything under here by that number. So this started off as a 1. Now I'm multiplying it by 2. It's going to be a 2. This started off as a 1. I multiply that by 2, and I get a 2. And look, check it out. How does that change my equation right here? Well, now, instead of a 1, I've got 2. So 0 plus 2 equals 2. Hey, check. That one's now balanced and, oh, fudge. Hopefully you're seeing it right now, right? What did I do? I changed this one up here, right? Not only did I make that one a 2, but I made this one a 2. Now, in the first line, we have 1 plus 0 equals 2. There is no way my calculator is going to tell me that's right. So now this one is unbalanced. But we can go back and we can fix that by doing the same thing, right? I've got a 1 on this side. I need to turn it into a 2. All you got to do is multiply it by 2. So if I put a 2 there, that becomes a 2. And now look at it. Check. 2 equals 2. Everything's good and balanced. Go ahead and work on the next one. That video should be posted up next. And hopefully I'll do a video for every one of these. Good luck.